Hello friends, today I am going to explain the Java program to sort an array of integers using bubble sorting algorithm. Bubble sorting algorithm is an important sorting algorithm which is a very simple sorting algorithm, a basic sorting algorithm. Here I am going to explain how this bubble sorting works. Okay, of course, as an introduction, it is a simple sorting algorithm. It compares each pair of adjacent items. Items means adjacent integers and swaps if not in order. The passes is repeated. Passes means iteration. That is, it compare with one another. The adjacent elements are compared with another. This is called passes. And these passes is repeated until no swaps are needed, which indicates the list is in order. Okay. So, bubble sort is a basic, simple algorithm which compares that two adjacent elements together, and it will rearrange them if they need a sorting if needed. Okay, so I will explain how this works. As an example, I have taken 5 numbers, integers in an array. That is, this is an array A which contains 5 elements: 5, 3, 8, 4 and 6. This is the initial array. This initial array is unsorted because first comes 5, then comes 3, then comes 8, then comes 4, then comes 6. This is not in an ascending order or in descending order. This is an unsorted array. So in A0 we stored 5, A1 we stored 3, A2 we stored the integer 8, A3 we stored the integer 4, and in A4 we stored the integer 6. So 0 to 4, that is 5 integers we are stored in an array A, and each elements are stored in corresponding adjacent array values, that is A0, A1, A2, A3, A4. We have to, our task is to sort these integers and in such a way that the final array is in a sorted manner. This is initial array is in unsorted manner. Okay, this is step 1. Step 1, compare the first two elements, that is compare A0 and A1. Compare A0, A0th element is 5 and A1th element is 3. Compare 5 and 3 such that A0, check whether A0 is greater than A3. If A0 is greater than or equal to A3, or A0 is greater than A3, A0 greater than A3, then we have to swap. That is, the second element is lesser than the first element, means the second element lesser than first element, so we have to swap. That is, A0 is swapped with the A first element. So A0 and A1 are swapped. A0 initially A0 is 5 and A1 is 3. After swapping, A0 is 3 and A1 is 5. So after step 1, that is swapping the first two elements, we will get 3, 5, 8, 4, 6. Okay, the first initial array of elements are 5, 3, 8, 4, 6. As part of a bubble sorting algorithm, we have check whether A0 is greater than A1. If if the answer is yes, if that statement gives an yes answer, then it will swap. What happened here? If A0 5 is greater than A1 3, so what happened? They simply swap together. Adjacent elements are compared and swapped accordingly. So here the adjacent elements are swapped and 3 comes in the position of 5 and 5 comes in the position of 3, and this is the new array after step 1. So step 2 will continue with this new array only. Forget about this first array. Now the array is filled with elements 3, 5, 8, 4, 6 in this order. A0th element is 3, A1 is 5, A2 is 8, A3 is 4th and A4 is 6th. Okay. Then step 2. Again the step continues like this. That is second step. This is the second step array. Here again the continue with then the pointer will point to the second element and third element. Now we will compare A first element and A second element. Compare A1, A2. Check whether A1 is greater than A2. Is A1 greater than A2? No. So no swap will be done. if A1 is greater than, or the elements we are checking is first element is greater than the second element, swapping will be done. Here 5 is less than 8, so no swapping. So the final array after step 2 is 3, 5, 8, 4, 6. No change, array will be like this. The next step, in the next step of execution will continue with this array only. Okay, 3, 5, 8, 4, 6. It's not in order, we have to continue the process. Again the pointer will point to 2 and third element, second and third element, that is 8 and 4. That is the step 4. Step 4 that will be comparing A2 and A3. Compare A2 with A3, whether A2th element is a second element, the third position, that is the third position element is greater than the fourth position element, or A2 is greater than A3. Yes, 8 is greater than 4, so we have to swap. So what will be the final result? 3, 5, swapping 8 and 4 together. 8 will comes in the place of 4 and 4 will come in the place of 8. That is A2 will be filled with the 4 and A3 will be filled with the 8. So the new array after step 4 is 3, 5, 4, 6, 8. Again the step continues. We will compare what happened A3 with A4. A3. First A0, A1, then A1, A2, A2, A3, then A3, A4. Last step we have reached, comparing A3 and A4. Here we have come to know that A3 is greater than A4, so there is a swap needed, and 8 is swapped with the 6. So in the position of 8 comes 6 and in the position of 6 comes 8. So the final result, or the result after step 5 is 3, 5, 4, 6, 8. Now this what this implicates is that the last element 8 is in position after the first iteration of bubble sort. After the first iteration of bubble sorting algorithm, the last element, fourth element will be in position. Okay, or the nth element will be in position. 8 is now in position. Repeat these steps, that is 1 to 5, that compare A1, A0, A1, compare A2, A3, compare A3, A4, compare A4, A5 until no more swaps required. Okay, this is the process of bubble sorting algorithm. I have done it here. That is again our final array. The final updated array is 3, 5, 4, 6, 8. That is A0, 3, A1, 5, A4, A2, 4, A3, 6 and A4, 8. 8th element is in position. Continue. Compare A0 with A1. Check whether A0 is greater than A1. Sorry, here it is A0 is greater than A1. A0 is greater than A1. No. So no swap is needed. Again coming to step 2. A1 is greater than A2, A1 greater than A2, yes, 5 is greater than 4, so swap is needed. So 5 comes in the position of 4 and 4 comes in the position of 5. This is the final array. This is the new array. 3, 4, 5, 6, 8, swapping done, and the 3, 4, 5, 6, 8 is in the array. Again A2 with A3, check whether A2 is greater than A3, A2 greater than A3. A2 is not greater than A3, so no swap is needed. Again the new array is 3, 4, 5, 6, 8. Here again checking the A3 with A4. Check whether A3 greater than A4. Yes, A3 is not greater than, no, A3 is not greater than A4. A3 is 6 and A4 is 4. They are in position, so no swap is needed. So the swap comes to an end until no swaps are found. Again when we continue the same, A0, A1, no, A1, A2, no, A2, A3, no, A3, A4, no. So no swaps are here. No swap, no. Again this is until no swaps are found, the iteration is finished and the array will be in a sorted order. We can finally print the array A. Our array is A. Array A is array. We can system.out.println. In the for loop, if we are trying to print the array, we will get the sorted array 3, 4, 5, 6, 8. So what is the procedure here? First, initially this order, every elements are stored in the corresponding array. from 0 to n minus 1. If there is 5 elements, then a up to a n minus 1 will be filled. Okay, a n minus 1 means a 5 minus 1 a4, because it is starting from 0, not 1, it is starting from 0. Array always starting from 0th position. Then compare a0 a1. If a0 is greater than a1, then swap and continue the process. If a0 is not greater than a1, then continue with the other adjacent elements. Okay, a0 a1, then compare with a1 and a2. Again a1 and a2 comparison, it seems there is no swapping done, and again the new array is formed. Again a2 and a3 we have to compare. By comparing a1 and a2, no swapping is needed. a2 a3 comparison, here swapping is needed because a2 is greater than a4 a3, so 4 and 8 are swapped. Then again a3 and a4 is compared. Here also there is a swapping needed since a3 is greater than a4. Then again swap, and the final array is 3 5 4 6 8. We have to continue this step until no more swaps required. That is, by comparing this a0 a1 no, a2 a1 a2 no, a2 a3 no, a4 a3 a4 no. For every adjacent elements, the swapping is no. The answer to swapping is no. Until the no swaps are found, we have to repeat step 1 to 5. These steps we have to repeat. Comparison, then first compare the adjacent elements, then swap, adjacent element comparison, swap, adjacent element comparison, swap, until no swaps are found in this sorting. This is the step 4, bubble sorting. The final array will be printed as a sorted array. That's all.